Philip Stoughton. I'm at Electronica 2024 and I am with Jack from Jiva Materials. Jack, good to talk to you. You're kind of the brains behind this whole project. Tell me, before we get on to the detail of the product, tell me the motivation behind the design.
So it all started at university back in 2017. I was given a brief. I was given a brief by my design tutor to choose a waste stream to try and optimise. So did a bit of research, looked into the size of the waste streams, and I found out that electronic waste is the fastest growing waste stream in the world.
Yeah, absolutely.
Obviously, there's a huge demand for electronics nowadays. Lifespan is decreasing in these products, and being a complete newbie into the industry, I did some research, found out that there's these things called PCBs. They're common throughout pretty much every product out there, and I did a bit of looking into them in terms of what the raw materials were. So they're predominantly glass fiber, epoxy resin, flame retardant as well. So I thought, why can't we just find a way of substituting these materials with more environmentally friendly alternatives? So took the glass fibers, replacing the natural fibers, and took the epoxy resin, replaced it with a biodegradable, non-toxic and water-soluble polymer.
Okay, and the idea is that obviously at the end of the board's life, you remove the components first, and then you can dispose of the material. Is that the idea?
So this example here, this is an assembled board. So this could actually be immersed into hot water. The polymer that we use will then absorb the water, soften, and that will then allow the board to delaminate, and the electronic components can then be removed as part of the recycling process. So the recycling process works best with single layer boards. So LED lighting is a very good example of where our technology would work well. You can then remove the solder mask with the copper attached, and the SMT devices still mounted onto the copper. So much more efficient way of doing things than the incineration and the shredding which currently goes on with existing boards, and we can have a much more concentrated waste stream of the precious metals.
Yeah, no, absolutely makes sense. And obviously you're doing it currently on single-sided and double-sided, but not on multi-layer?
Not just yet. It's on our technical roadmap. So last year was a big development for us to reach the 2-layer plated through-hole technology level. We're targeting 4-layer boards by the middle of next year as a proof of concept. But we're at the moment, to be honest, we're very, very busy with the interest we're receiving for a 2-layer plated through-hole board. Yeah,
and I mean, if you look at the volume of laminate by square foot rather than by cost, there's a lot of single-sided and a lot of through-hole plated stuff out there. So there's an opportunity there. So you mentioned you have a lot of interest. Is that largely from the OEMs that use the board that are kind of responsible for the end of life, or is it more from the PCB manufacturers?
So our business model is to go directly to the OEMs. They're the ones who typically make the decisions. They will tell their subcontractors and the designers how they want their boards. And our goal really is to have Soliboard on the drawing of these designs that are then sent to the manufacturers. So
they'll spec it in.
So this is an example of one with a project with Bosch that we've done, and you can see that we have Jiva and Bosch on the same branding, on the same board.
Where did the name Jiva come from, by the way?
I was looking for a very short, catchy name. Jiva is actually Sanskrit for basically anything imbued with a life force. So I thought it was very fitting of the natural fibers and the more environmentally responsible materials that we use in our products. And it just so happened to be available. So it's been great.
Yeah, and when you look at these kind of products where sustainability is kind of at the core, I look at them from an industry point of view, and I think that's great. And when the market's good, people are very concerned about sustainability, but it still has to be commercially viable.
Sure.
What's the kind of price differential at the moment, and do you see that reaching parity in the future?
So the stage we're at now, our material itself has about a 10 to 15% premium over FR4.
Yeah.
So if FR4 is 30 euros per square meter, our material will be 33, which has been trialled and tested with our customers, and that's the price point that they're willing to accept for the green credentials and benefits that we're able to offer them.
Yeah.
So, but because our material is designed to be processed through existing and standard PCB fab facilities, it means that there's no premium in terms of the manufacturing. There could actually be energy savings as well, because we assemble our boards using low temperature solder, so there's energy savings and cost savings in terms of the energy that goes into assembling.
Yeah. So when you look at it from a point of view of a laminate, it's maybe 10% more, but when you look at it from a point of view of a PCB, it's a much smaller percentage more.
Definitely,
and then when you go to PCBA, that percentage comes down.
Exactly.
It comes down even further. And you know, if you think of a product like this and you look at the potential of it, it's obviously large volume potential. What's the strategy in terms of manufacturing? Is it license deals or?
That's the model we were looking at initially. I think it's proven to be better for us to have more control over the supply chain. So at the moment we have the raw materials which are processed into the pre-preg with our partners in Hungary and Slovakia. So the pre-preg then comes back to the UK. We consolidate it into panels, and we're then producing PCBs with our UK-based PCB fab partners. Yeah.
Yeah. Okay. And if you're going to much higher volume, is there a strategy to license it to more people, or is the strategy to make more laminates?
Yeah. So I think when we have the material clearly defined and everything's been optimized, then we will work with our PCB fab partners to basically walk our material through their facility.
Yeah.
I mentioned it can be processed through industry standard technology and processes. There's just a few tweaks that needs to be made in terms of feeds and speeds and time and those sorts of things. So it typically takes us about 6 to 8 weeks to get a PCB fab partner fully aligned and used to working with our material.
Yeah, and get you on board. And with respect to design and design restrictions, people need to think about when they're designing for this solution.
We're actually pretty close now in terms of the capabilities which FR4 can offer for a 2-layer plated through-hole board. There's not really too many that comes to mind. We do have a set of design guidelines that we're able to share if customers are interested in working with us.
So, yeah, and it makes sense, doesn't it, to have those design guidelines if you're asking them to then put this as a specified laminate on the drawing that goes out with the product. Excellent. Well, thanks so much for talking to me. Good luck with the product. I think it's really interesting. We'll be watching and seeing what happens next with you guys. Thanks so much.
Appreciate it. Thank you.